Welcome to Sora Forensics, where we explore the fascinating world of forensic science. Today, we'll be dealing with the topic of latent fingerprints and how they are developed. Development of latent prints. Latent prints are the most prominent example of Locard's principle of exchange, hence, the great importance of visualizing them onto useful evidence. Palmar and plantar surface is completely free from hair and sebaceous glands, but there is profusion of sweat glands, called acrines, the composition of which forms the basis for latent fingerprint residue. The salts predominant in perspiration are sodium and potassium chlorides, with the organic fraction containing mainly amino acids, urea and lactic acid. Free fatty acids, triglycerides are also present. Types of surfaces. For non-porous surfaces, for example glass, gloss-painted surfaces, metal and plastic. Visual examination, oblique illumination may reveal latent fingerprints, particularly if the surface is smooth and clean. Tests, vacuum metal deposition, VMD, fingerprint powders, superglue fuming, small particle reagent, SPR, iodine fuming. For porous surfaces, for example paper, wallpaper, cardboard and matte emulsion painted surfaces. The reagents used for these surfaces react either with amino acids, fats and lipids or chlorides absorbed into the surface. Visual examination is less likely to reveal fingerprints on porous surfaces. Tests, DFO, 9-hydrin, superglue fuming, physical developers, silver nitrate method. Fingerprint powders. Powdering is one of the oldest techniques for detecting fresh latent prints. Different colored powders are used. Many powders has been developed such as milled aluminum or brass, or molybdenum disulfide are more sensitive and effective at developing fingerprints on smooth, clean surfaces than the more traditional black or white powders. In case of contaminated surfaces, granular black, chalk and mercury, or white powders, lead carbonate or French chalk, are more suitable. Fluorescent fingerprint powders are designed to develop latent fingerprints on multicolored surfaces. The powders have fluorescent properties and may offer a better contrast to the background than conventional powders. Example: anthracene powder. Superglue fuming, also known as cyanoacrylate fuming. It is composed of methyl or ethyl cyanoacrylate which polymerize with latent prints. It reacts with fatty acids and amino acids. The prints developed are like hard white polymer. It glows under UV. Vacuum metal deposition. VMD is most sensitive, being capable of detecting monolayer of fat by sequential deposition of a thin coating of thermally evaporated gold followed by zinc. It can develop fingerprints on surfaces that have previously been wet or even submerged in water for extended periods of time. Fingerprints developed by VMD are of a much higher definition, often to third-level detail, and have superior contrast as compared to other techniques. If fingerprints are not revealed by VMD, superglue, powders or other techniques may be used subsequently. Small particle reagent. SBR consists of a suspension of molybdenum disulfide suspended in aqueous detergent solution which is applied by spraying or immersion. The molybdenum disulfide particles adhere to fats deposited in the fingerprints, final color, a gray-black image. Iodine fuming. It is one of the oldest and cheapest methods and can develop recent prints on porous and non-porous surfaces like cloth, skin, paper etc. Iodine fumes are absorbed by fingerprints fats and oils to form a brown image which is photographed immediately because iodine is volatile. If starch water is sprayed it can be preserved for months. Color is blue with starch. DFO, 1,8-diazine-9-fluorinone, it is the most sensitive reagent available for detecting fingerprint on porous surfaces. DFO reacts with amino acids deposited in the fingerprints to produce a faintly colored but intensely fluorescent compound which can be easily photographed. Since amino acids are soluble in water, DFO or 9-hydrin cannot be used to treat porous surfaces which have been wet. Pale pinkish product formed best for fingerprints on paper. Fluorescence shown at excitation wavelength -470 nanometers and emission wavelength 570 nanometers, 3x faster than 9-hydrin. 9-hydrin test. First time used by Odin and Hofsson. 9-hydrin can be considered as the hydrate of indane 1,2,3-trione. Trichdehydrandiene hydrate. 9-hydrin is a widely used chemical which reacts with amino acids and produces a deep blue or purple color known as Raman's purple. Very slow technique. Temperature is increased to increase rate, heat at 26 degrees Celsius to 38 degrees Celsius. Samples as old as 50 years also developed. Solvents for 9-hydrin, CFC 13-EKAR clonofluoresol, hexane, HFE 7100, HFC 4310. Physical developer. It is the only available technique for detecting fingerprints on a wet porous surface. This reagent is an aqueous solution of silver nitrate containing a Fe2/3 redox couple and two detergents citric acid and dodecylamine acetate. Absorption of metallic silver particles of fatty acid and lipids. The developed fingerprints are gray-black in color and recorded using conventional photography. Silver nitrate method. Reaction of silver nitrate with chlorine present in the fingerprints. Effective for porous paper, cardboard, plastic, wood. Prints on wet articles can't be developed. Silver nitrate reacts with chlorine to form silver chloride, giving us a gray color on visualizing under UV.